Hello, this is Jack Jackson. In this video, we're going to quickly review about composition of functions, and we're going to do that to help us get ready for the chain rule. Okay, so in composition of functions, you have the output of one stage or link in your chain becomes the input for the next function, the next link in our chain. So we chain these functions together by this what's called composition. So here I have a GeoGebra applet that's going to help us with this and then ultimately help us with looking at the chain rule as well. So you think of the inner function as being here g of x equals x squared divided by 4, or whatever we type in here. And that gives us this blue graph in the xy plane, which is this plane here on the left. The value of a then is given by this slider here. So for example, if it's 2.5, that's given by this horizontal length. And then we go up and get this vertical length, which becomes the output. So that generates a point, 2.5 comma 1.56, at least approximately. And then we then what we do is we take that and put it inside the function f. But since the output here is a g value, I'm going to call the output g or u, and I'm going to write f as a function of u. So f of u is e to the u. So I'm going to grab the function f over here in the y plane. So the horizontal axis is the u axis now, or g axis. So what was a vertical amount here, or an output, 1.56, becomes the input right here. So notice that is 1.56. This vertical purple distance is the same as this horizontal purple distance in the other plane. The output of the first stage becomes the input for the second. Then I do e to that power, and that gives me this point here on this graph. It's approximately, e to the 1.56 is approximately 4.77. And so that gives me this orange length here, which is an output. That output is then brought over here, the exact same orange length here, but put it above the original x, and that gives me the output on the composition function. So that gives us the ordered pair 2.5 comma 4.77. Look at the ordered pairs. This is the ordered pair from g, the first function, or inner function, input 2.5, output 1.56. The output here, our second coordinate, becomes the first coordinate here, 1.56, and output 4.77 on f, and the output of f is the final output on the composition over here. So you take the first coordinate from this one and the second coordinate from this one, where these two are matching, and that gives us our ordered pair on the output. It's illustrated by the diagram here. You start with a, then you do g of that, and then do f applied to that. And then the shortcut going straight from here to here is the composition function. And notice that we read this backwards. This is f of g of x. We start with the, well, I say backwards, I mean right to left. We start with the x, then we apply the function g, then we apply the function f. So there's a very quick review of chain rule. Look at my algebra videos for some more, not the chain rule, but just composition of functions. Look at my algebra notes for more examples of composition of functions. We're going to go on and see how we can find derivatives of this in the following videos.